Hi, my name is Vincent, and today I want to take a look at segments formed by intersecting chords. So we have the problem in circle O, chords A, B, and CD intersect at point E. If AE equals 10, EB equals X, CE equals 12, and ED equals X minus 1, find the length of line segments EB and ED. So the first thing we want to do is label all of the line segments that were given to us. So we know that AE, the length of this line segment is 10, so we can label this piece 10. We also know that the length of EB, well, they gave it to us in terms of a variable X, but we can still label this X. Next, we know that the length of line segment CE equals 12, so we can label this 12. And finally, we were given that the length of line segment ED is X minus 1, so we can label this last piece here X minus 1. So now to find the length of EB and ED, we're going to use the segments formed by intersecting chords theorem, which states when we have some circle O with intersecting chords AB and CD, if they intersect at some point inside the circle, in this case E, then the product of the segments formed by the intersecting chords are equal. Or in other words, we have AE times EB equals CE times ED. So applying this theorem to the circle in this diagram, we could set up the same equation because we have intersecting chords AB and CD. They intersect at point E. So we could set up the equation AE times EB equals the product of the other segments of the chord. So we have CE times ED. So now all we need to do is substitute. We have AE is equal to 10, so we could substitute 10 for AE. We also have that EB is equal to X, so we could replace EB with X. I'll put this in parentheses. And we have CE equal to 12. And we also have ED equal to X minus 1. So now in the next line, well, 10 times X is just 10X, so we could just write this as 10X. But now, for the right-hand side of the equation, we need to distribute this 12. So we have 12 times X, and then 12 times negative 1. 12 times X is 12X. 12 times negative 1 is minus 12. So after we distribute, now we can simplify a little bit more. We're going to subtract 10X from both sides. So now 10x minus 10x will cancel. So now we have 0 equals 12x minus 10x is 2x. This minus 12 will just fall down. And now to solve for x, we're just going to add 12 to both sides. And now we have 12 equals minus 12 plus 12 cancels. So we have 12 equals 2x. And now the last step, to solve for x, we're just going to divide both sides by 2. So now we have x equals 12 divided by 2, or x equals 6. So now we were given that EB equals x, and we were given that ED equals x minus 1. Well, we just found out that x equals 6. So we could replace x with 6, and we could do the same thing here. We're just going to substitute in 6 for x. So now that tells us that the length of EB is 6, and the length of ED is 6 minus 1, so the length of ED is 5. So now we could try these values out. And what I mean by that is, let's for a second consider EB equals 6. Now we have the product of the segments formed by the intersecting chords are congruent. So now let's try it out. We have 10 times EB, which is 6. So 10 times 6 is 60. And now we have CE, which is 12 times ED, which we just found to be 5. And 12 times 5 is also 60. So these answers do check when we plug them back into the theorem. Okay, well, this is going to conclude this problem on segments formed by intersecting chords. Thank you all for watching, and I hope this was helpful.